Hello everyone, welcome back to my YouTube channel. Myself Grishma, I am pursuing my BE in Sri Venkateshwara College of Engineering. Today's course title is Mathematics and course code BMATS 201. Topic Graphs and Network. Contents that we are going to learn this PPT are Introduction to Graphs and Networks, Vector Spaces and Linear Transformation, Basic Concepts of Graph Theory, Subspaces, representing graphs and networks as vector space, Linear Combination, Different types of graphs. Graphs used to model pairwise relation between objects. Generally, a network can be represented by graph. Many practical problems can be easily represented in terms of graph theory. And definition of graph is a collection of nodes and edges denoted by G is equals to V comma E, where V is nodes, that is vertices and points, E edges, that is links, arcs between pair of nodes. Graph size parameters n is equals to modulus of V and m is equals to modulus of E. Example of graph. Here in this example n is 6 where n is nodes and m is edges. Vertices V is equals to 1, 2, 3, 4 and 5, 6. Edges are 1 and 2, 1 and 5, 2 and 3, so on. N of 4 is equals to neighborhood 4, where that is 6, 5, 3. Vertex and edge. Vertex or node. Basic element drawn as node or a dot. Vertex set of G is usually denoted by V of G or V or VG. Edges or arcs is a set of two elements drawn as a line connecting two vertices called end vertices or endpoints. The edge set of G is usually denoted by E of G or E or EG. Neighborhood. For any node V, the set of nodes it is connected to V an angle is called its neighborhood and is represented as N of V. These are some examples of graphs. First one is unidirected graph and second one is weighted graph. Third one directed graph. Last one is graph with self loop. Simple graph, that is also called as unidirected graph, and this is the drawing of simple graph. Simple graph or unidirected graphs without loop or multi-edges, where A is equals to AT. Coming to this weighted graph. Weighted graph is a graph for which edges has an associated weight. Empty graph. Edgeless graph. It does not contain any edges, where it is a null graph, no nodes, obviously no edge. Directed graph or digraph. Edges have direction, where A factorial is equals to AT. We can see the diagram with loop, node, arc and multiple arc. We have types of graphs. First one is bipartite graph. Bipartite graph is a graph in which the vertex set can be partitioned into two sets W and X so that no vertices in W share a common edge and no vertices in X share a common edge. Chromatic number of bipartite graph is 2. Types of graphs. Next one is null graph. Null graph which contain only isolated nodes, that is set of edges of graphs is empty, so it is called as null graph. Regular graph. A graph in which each vertex has the same number of neighborhood, that is every vertex has the same degree, is called as regular graph. Regular graph with vertex of degree k is called k-regular graph or regular graph of degree k. Coming to the next one, complete graph. Complete graph is a graph in which each pair of vertices is joined by an edge. Complete graph contains all possible edges. Examples of types of graphs are, first one is null graph with 3 vertices. where it does not contain any edges. The second one is complete graph with 3 vertices. Third one is 2 regular graph with 4 vertices. D is bipartite graph with 5 vertices. Next, let us know graph representations. Representation of graph. Two most common ways to represent graph is adjacency matrix or adjacency list. Adjacency matrix. Adjacency matrix is a 2D array of size v into v, where v is the number of vertices in a graph. Let the 2D array be adjacent slot adjacent which is equals to 1 indicates that there is an edge from vertex I to vertex j. Adjacency matrix for unidirected graph is always symmetric. Adjacency matrix is also used to represent weighted graph. If adjacent ij is equals to w, then there is an edge from vertex I to vertex j with weight w. Adjacency list. An array of lists is used. Size of array is equal to the number of vertices. Let the array be array and entry array I represent the list of vertices adjacent to the ith vertex. This representation can also be used to represent a weighted graph. A weights of edges can be represented as list of pairs. Next, coming to the topic vector space. Let V be an arbitrary non-empty set of objects on which two operations are defined, addition and multiplication by scalar number. If the following axioms are satisfied, all objects u, v, w in V all scalars k and I, then we call V as a vector space and we call the objects in V vectors. First one, if V and V are object in V, then U plus V is in V. U plus V is equals to V plus U. There is an object O in V called a 0 vector for V such that 0 plus U is equals to U plus 0 is equals to U. This is the example of vector space. Question is, determine whether the set of V of all pairs of real numbers x, y with the operators x1, y1 plus x2, y2 which is equals to x1 plus x2 plus 1 and other one is y1 plus y2 plus 1 and k of x, y which is equals to kx, ky is a vector space. Properties of vectors. Let V be any element of vector space and let C be any scalar. Then the following properties are true. 0 V is equals to 0, C0 is equals to 0. If CV is equals to 0, then C is equals to 0 or V is equals to 0. Minus 1 of V is equals to minus V. Coming to the introduction to linear transformation. A linear transformation is a function which is represented by t that maps a vector v into another vector space which is represented by w, where t is to v mapping gives a w, where v, w is to vector space, where v is the domain of t, w is the codomain of t. You can see the diagram where v is the domain and w is a codomain. Note, a linear transformation is said to be operation preserving. T of v u plus v is equals to T of u plus T of v, where T of u plus v is addition in v and T of u plus T of v is addition in w. Second note is, a linear transformation T is to v from a vector space into itself is called as linear operator. Thank you for watching my video. Please like, share and subscribe.